Hey again. Our first of a pair of causation lectures is called Forming Causal Statements, not casual, don't misread that. Forming Causal Statements, and then we're going to look at a subsequent one called Confirming Causal Statements. So our task here, as I say in the next slide, is to make claims with your head, not with your feelings or opinions. All right? So we're looking at a little more formal logic in this course. Not quite as formal as the kind of logistical syllogisms, those things you see with the weird kind of mathematical formulas, if P then Q and that sort of thing. That's kind of beyond where we need to be, and I don't feel it's as useful as just looking at argumentative type of language for putting our claims together. So I'm going to stick with the world of language that's most comfortable for me and that I think works best for everyday academic argument. So, for example, go to this next slide again here. The textbook refers to claims as hypotheses, right? The hypothesis being the singular. That to me feels a little more complicated than it needs to be. We're going to stick to argumentative terminology where the thesis, if you had English 111, they might have called it a thesis statement, right? The centering part of your argument, of your essay, right, that you wrote. In argument, that thesis is called a claim. So claim is the word that we're going to be using throughout, and that's what we've already begun using that language. You're doing a problem solution claim, also addressing some causes and effects, okay? So that's the language that we're using. So what we're trying to do is avoid a type of fallacy, which is called post hoc ergo propter hoc, Latin for just because X comes first doesn't mean it caused Y, which came second. Right? That's really all it's saying. We'll be looking at a number of fallacies. Fallacies are just errors in reasoning, making a claim based on faulty information or faulty logic. So when we see X being an event and then Y following afterwards, we need to know for sure that X caused Y, that Y is a result of X. Just because one follows the other does not mean the two are linked. And your book points out three ways that we could do this. They call it principles of causation, and that's fine. We can look at their names for this. They say we should look at the unusual events and see if we can pair them together, and what happens with one happens with the other. We can look to see if a couple of groups or events have a common variable between them, and we can look at something called covariation. When one varies, does the other vary in the same way? All right, so let's look closely here. So causation, we already know that term. It means one thing causes another. So with paired unusual events, we're looking at a situation where both events are unusual, therefore they must have something to do with each other. And must, may, right? We talked about qualifiers already. We want to check for plausibility. Just because they're unusual doesn't mean they're linked, but because they're unusual, there is a higher probability. If your car started clanking like mine did a while back, after I had taken it to have the air conditioning fixed, took it home, it started clanking terribly. I thought, what is that noise? Is it some kind of belt? I know nothing about cars, but I was thinking of fan belts, that noise they make. I was thinking, gosh, it's kind of bouncy. Is it springs? I couldn't tell what it was. So I took it back in and said, you guys worked on it, now it's making a noise. Turned out the two were not linked. Just because they were both unusual, I don't take my car in very often, that's what we mean by unusual. And now it's making a noise, which is unusual. Cars don't make these kind of clanking noises. Didn't mean that they were linked. Come to find out, they were repaving in my neighborhood for quite a while, and they scrape up the asphalt and leave behind all this grit and gravel, and I guess one of those bits of gravel got stuck up inside something that was making this horrible clanking noise. So just because they're both unusual doesn't mean they are connected. It means they could be connected. But that's one of the first things you want to see. Are these things connected in a way because they both happened and they both happened at the same time and they were both sort of odd? are they just two independent coincidences, or do they actually go together? All right. Multiple occurrences of X may lead to Y, right? So I was talking in this first, I kind of came up with a scenario. There was a full moon last night. It doesn't mean that the moon had anything to do with the plane crash this morning, right? It's not plausible based on what we know about planes and full moons, right? Could happen, but it seems unlikely. But if we've had 10 full moons, one each month for 10 months, and every time there's a full moon, the next day there's a plane crash, something might be going on. Now, it's still not necessarily plausible that the full moon is causing the crash, but maybe something else is going on. Maybe that's the only time this particular rocket launcher works, or they can get permission to get out of the house and shoot down the plane. I don't know, right? There's probably something, though, that connects them together. Does that make sense? Okay. And finally, covariation. Another term for this is correlation. You might have heard that in a statistics class or a math class somewhere along the way. When X increases and Y increases, the two, again, may be correlated. If X goes down and Y goes down, again, the two may be connected. You'd have to do more research, but that's a good place to start, is that the two might have something to do with each other. All right? No matter how the causal statement is arrived at, confirmation through research or experiment will be needed, right? So no matter what it is, we can't just say, oh, one happened, then the other happened, I'm done. No, you need to research that. Okay, so that's coming up with your causal statement.